Whenever I work on an example like this, I always try to give you an example from the textbook, but not an example that's already given and not an odd numbered problem from the exercises. Sometimes I make up my own and sometimes I use an even numbered problem from the exercises. The main reason for that is that with an even numbered problem from the exercises, you have another model to go from. You know it's in the textbook, or you might find it in the textbook, but it's not one that's already worked out for you in some other place, right? Occasionally I'll resort to using a problem from the examples right in the textbook. But for the most part, I try to use exercises from the problems from the exercises. But I'm not going to do an odd numbered one because that answer for that one's going to be in the back of the book. And I want you to be able to try that problem yourself and then check your answer. So for this problem, I'm going to do question number 34 from 7.3. And here I'm asked to prove the given identity. I'm just going to write prove. The identity is the sine of t minus the cosine of t quantity squared equals 1 minus the sine of 2t. That's what I'm asked to do. To do it, I'm going to start with statement proof and then either left-hand side or right-hand side. If I have time, I'm tempted to do this one two different ways because it appears to me, just on the surface, that I could either start with the left-hand side and expand that, or I could start with the right-hand side and expand that, but I'm not sure which I'm going to do. So let's just start with the left-hand side. So that means that I have to write LHS equals and then copy it out. Sine of t minus cosine of t squared. Notice that there's an equal sign here. And what I'm going to do now is start writing equal signs down in a vertical pattern below this one so that each line below is equal to the line above. If I expand this is from algebra. This is like saying a minus b squared, and that's going to be a squared minus 2ab plus b squared. If you don't remember how to do that, then that's something you might want to come and have a quick conversation with me about, and I can show you, or I can show you in class. So here I'm going to get sine squared of t minus 2 times sine of t cosine of t. Sine is my a, right? A minus b, a squared. Sine is my a, cosine is my b. A squared minus 2ab plus b squared. So plus cosine of t squared. That's my left-hand side expanded. Okay, now I have noticed as I work through this that this 2 sine cosine, right, that's the sine of 2t. That's the double angle formula. That's this sine of 2t is equal to this. So that makes me want to go, what about these other two terms? Well, the sine of squared of t plus the cosine squared of t are going to equal 1. And that's the other thing I need for my right-hand side. So I'm going to start by reordering these. And then I need to go back and make sure I've included some annotations. So let me get rid of that. And this is the first statement you don't have to justify because it's just a restatement of either the left or the right-hand side. The second one is algebra, right? This I got from here to here just by using algebra. Right? I happened to use trigonometric expressions in the terms, but all I did here was an algebraic skill, right? That's all I did here. And in fact, this is just a reordering, so that's algebra as well. All right, now I've reordered these, and I'm going to make the observation that these two here, when you add those together, that's the Pythagorean identity, so you get 1. So that's going to give me 1 minus whatever's left over here, which is 2 sine t cosine t. And how did I do that? Well, that was the Pythagorean identity. And then notice that 2 sine t cosine t is sine of 2t. I can rewrite it one more time as 1 minus the sine of 2t. How did I do that? That was a double. Here's a short shortcut symbol for angle. If you don't want to write the word angle, you can use that symbol. It's literally an angle with a little arc through it. So double angle formula. Now, do you have to use my exact words here? No, absolutely not. There are many ways of expressing what it is you're doing here. I would encourage you to use algebra just because that's probably the shortest way of expressing that all you did was, all you used was a skill that you brought with you from another class, a prerequisite skill. But you do want to identify the things that the ideas that you use to get from this line to this line. How did you get here? You use the Pythagorean identity, right? From here to here. The Pythagorean identity is sine squared plus cosine squared equals 1. So you don't need to necessarily include this information. I just did that for your benefit to point out that that was what we were doing. But what we did use the Pythagorean identity, and I've made a note of that right here. Now it looks like we're done because we got the right-hand side, but we haven't written equals right-hand side. Now, I know that probably seems trivial and unimportant, but I want you to see the connection that you have created a link between the left-hand side and the right-hand side, then each one of these steps is equal to the one before it. So this last step, writing equals right-hand side, that's important. I want you to do that. Okay, now I'm going to do the same problem, but starting with the right-hand side. I'm going to need to erase the screen to do that, and I'm going to do it fairly quickly. The main reason for doing it is just to show you that sometimes it can be done. In fact, always it can be done, but sometimes it's easier to see in one direction, kind of what each next step is going to be, than it is in the other direction. I think in this case, it's left-hand side first. Makes more sense. It's going to be easier. It was pretty easy once we just expanded the left-hand side. We could see the parts of the right-hand side kind of falling into place. I think that's going to be less obvious if we do it the other way around, but I do want you to see that the logic holds and you can do it in either direction. So we're starting with a clean slate, but this time I'm going to start with the right-hand side. So I need to recopy the right-hand side of the equation. Keep in mind that what we're trying to do here is prove that this equality is true. So I can't play with both sides and hope that, it's like I can't add one to both sides, because if you add one to both sides, you're assuming that they're equal to start with, and therefore it's a balanced equation, and you can continue to keep it balanced by adding one to both sides or by dividing both sides by 2. But we don't know that it's a balanced equation, right? We're asked to prove that it's a balanced equation. So we have to start with one side and show that it looks like the other, or show that it can be made to look like the other. Here, I know that the sine of 2t can be written as 2 sine t cosine t. Okay, that doesn't seem to help very much, since I'm pretending I've never done this before and I've just chosen to work with the right-hand side. I don't feel like I can do much more with this here, but I do know a couple of different ways that I can write 1. 1 is the tangent of pi over 4. That's not going to help me much. 1 is, let's see, 1 is equal to the cosecant squared minus the cotangent squared, or the secant squared minus the tangent squared, or it's equal to the cosine squared plus the sine squared. Those are the 3 Pythagorean identities. Well, my question only has sines and cosines in it, so maybe I'll try changing 1 to cosine squared of t plus the sine squared of t minus 2 sine t cosine t. That is the use of a Pythagorean identity. The one above it was the use of a double angle formula. All right, it's still not super obvious. I mean, it kind of is because we've done this problem already in reverse. But this is what I mean by it can be done, but sometimes it's easier in one direction than the other. Now, if you're astute and your algebra is strong, you might recognize that this is in a different order. This is minus 2ab here, so we could have this as an a squared minus 2ab plus b squared. So I'm just going to reorder these. sine squared of t minus 2 sine of t cosine of t plus cosine squared of t. That's just algebra. And then I know, because I know algebra so well, that that factors as the sine of t minus the cosine of t squared. And that is also algebra, but it's also our left-hand side. So now I can write equals left-hand side. So this proof can be done in either direction, right? It was a lot easier to see in the left-hand side first direction than it was in the right-hand side direction. The lesson I hope you take away from this is that sometimes if you're working on a proof and you start with the left-hand side, or you start, well, let's say you start with the left-hand side and you just feel like you're stuck, try it from the other side. See if working from the right-hand side is actually easier. Now this section is actually about double angle as well as half angle formulas and reduction formulas. So we have two different types of formulas we haven't even talked about yet in this same section. So let's call it quits for this video and start talking about the reduction formulas. We'll do that next.